Kinematics is all around the world. Today, we will explore kinematics in floorball.
Kinematics, the branch of physics that deals with pure motion without reference to masses or forces involved in it. In this video, we will discuss acceleration, speed, velocity, distance, and displacement in floorball. Floorball is an evasive sport, officially played with 5 field players and a goalkeeper on each side. It has similarities with hockey. It is played with a stick and a ball with the holes where your goal is to shoot the ball into the goal. It promotes equality and fair play and solidarity. It originated in Sweden and is now played in all parts of the world.
Now in our first example, we have a player running towards a ball. And as a player, we want to find the shortest possible path, which we will do. In floorball, we can calculate for the shortest distance towards the ball. So in this example, we have a ball. It's moving forward and you want to get to it. In between you and the ball, there's a 2-meter gap. Now, you want to find the shortest path going there in order to get it the quickest and fastest way. This is known, so we can then solve for the displacement. We have the given here, d sub 1 equals 8 meters, d sub 2 equals 2 meters, and time equals 4.25 seconds. In order to find displacement, we need to find its equation, which is the square root of d sub 1 plus the square root of d sub 2 squared. Now we can substitute values is equal to the square root of 8 squared plus 2 squared, making our displacement 8.25 meters. Now we can also solve for the velocity, which is more or less the speed over the given displacement. Now in order to do so, we must first find its equation, which is displacement over time. And using this, we can substitute the values 8.25 over 4.25. So velocity would equal to 1.94 meters per second. We have two students who are going to go on a race. Using physics, let's find out who will win. Place your bets. With physics, we can actually know who would be faster. In this problem, we will be using graphs in order to help guide us. Now, there are two types of graphs, distance versus time, and speed. For Mateo, we draw a straight line. Put the speed at 3 meters per second. Second, speed versus time graph. We have Tyler with a line which is slanted upward to the right. And we will label 2.5 meters per second squared as its acceleration. On the other hand, for distance versus time graphs, we have Mateo's graph, which is a line sloping to the right at a medium type of slope. On the other hand, for Tyler, we have a slope that is really steep. Now it's time to get into the actual solving. So first, let's have our representation. And we have our given. Distance is equal to 10 meters for both. Tyler's acceleration is 2.5 meters squared. Velocity initial for Mateo, a is equal to 0. Velocity initial is 3 meters. And both of the times are unknown. Now for our equation, we have d is equal to vi times t plus 1/2 at squared. To solve Mateo's time, we already substituted values. Now we just have to simplify. It becomes 10 meters is equal to 3 time. Now we can divide this both by 3 in order to simplify it. So 10 divided by 3 gets our time. So time is equal to 3.3 seconds. To solve for Tyler's time, we already substituted values. Now it's just time to simplify. 10 meters divided by 1.25 seconds is equal to 8 meters. Now we have to square it to remove the squared, and we get the square root of 8, which would become 2.8 seconds. Therefore, we can conclude that Tyler would become the winner because Mateo took 3.3 seconds and Tyler would have just taken 2.8 seconds over a 10-meter stretch. We can also apply kinematics in shooting. In our last problem, we are trying to shoot a ball. Now, for example, we're 5 meters away from a goal, and we shoot. We would want to know if the ball went in. Our initial velocity is equal to 15 meters per second, our acceleration is equal to negative 4.9 meters per second due to gravity, and our time would be 5 seconds. In order to solve the problem, we will be using the third acceleration equation, which is distance is equal to initial velocity times time plus 1/2 a times t squared. We can then substitute our values. So d is equal to 15 times 5 plus 1 half negative 4.95 squared. So in order to simplify it, it becomes 74 minus 2.45 times 25. So 75 is minus 61.25. So distance is equal to 13.75. Given the initial velocity of 15 meters per second and the acceleration of negative 4.9 meters per second squared, we can still say that the distance traveled is 13.75 meters, which is well over the distance of 5 meters of you between the goal, meaning that you will shoot the ball, making each shot precise.
There's a problem that many athletes face. The problem is that athletes don't know specifically what to train based on what they need to improve on. This will cause them to train needlessly for areas in which they already excel instead of training in areas that they don't excel. Now, how do we solve this problem? We solve this problem by providing statistics by using kinematics as those statistics. These statistics will give them specific areas in which they can compare with other athletes so that they can find where they lack. If a person lacks in acceleration, we can use kinematics to find out whether they do or not, and if they find out whether they lack in acceleration, they can do training where it will improve their acceleration, like short, long sprints. But if their top speed is low and they would want to improve it, we would suggest longer sprints for longer distances to improve that top speed. Now, after all this, what do we get? We get better athletes because at a faster rate they are able to improve because they are able to tackle their weaknesses straight on using accurate data to consistently measure or act as a metric to measure how good they are in said field.